Nuclear war, crude oil, and one Soviet tank have in common? Why are military experts still arguing about the T-55 decades after it first appeared? In this video, you'll discover 4 incredible features that made the T-55 one of the most unusual tanks ever built. You'll learn why it was designed for a world living under the threat of nuclear conflict, what secret solutions shocked foreign specialists, and how Soviet engineers carried out an experiment that sounded completely insane. If you're interested in tanks, secret military projects, and forgotten war machines, be sure to subscribe to the channel and turn on notifications. There are many more fascinating stories ahead. Enjoy the video, and let's continue. At one point, they filled this tank with something no one expected. The result surprised even experienced military engineers. Stay until the end, because the most unbelievable story about the T-55 is also the least known. In the history of tank building, there are many machines that were considered a real breakthrough in their time. Some were striking for their powerful armament, others surprised with their speed or unusual technical solutions. However, most of these projects gradually faded into the past. They were replaced by more modern models, and they themselves remained only a page in military history. But something completely different happened with the T-55 tank. At first glance, this machine looks quite simple. It lacks futuristic technologies, complex electronic systems, or any revolutionary solutions that immediately catch the eye. Nevertheless, it is this tank that managed to achieve what many of its much more modern competitors could not. It has survived entire generations of armored vehicles, dozens of armed conflicts, and several eras of military development. The most amazing thing is that the T-55 remains in demand to this day. Decades have passed since its appearance. New tanks have been created with more powerful guns, modern armor, and complex fire control systems. It would seem that the place of the T-55 should have remained only in museums long ago. But the reality turned out to be completely different. Today, these machines continue to be in service in many countries around the world. In some places, they are used as main battle tanks. In others, they serve in reserve. And in others, they become the basis for completely new equipment. For many foreign experts, this fact remains a real mystery. How could a tank created in the late 50s of the last century maintain its relevance when newer machines have long since disappeared from armies? Even more questions are raised by the fact that the T-55 has gained a reputation as one of the most reliable combat vehicles of its time. In various climatic conditions, on different continents, and in the most difficult circumstances, it has repeatedly proven its ability to perform assigned tasks where other equipment faced serious difficulties. It is not surprising that foreign experts have spent years trying to understand the secret of this machine. Many of them studied its design, analyzed operating experience, and compared the T-55 with Western analogues. However, some solutions of Soviet engineers remained unusual and even incomprehensible to them. The secret of the popularity of the T-55 lay not only in strong armor or a powerful gun. Much more important was something else. This tank was created at a time when the whole world was on the verge of a completely new era. An era in which familiar ideas about war began to change rapidly. After the end of World War II, humanity faced a threat that could negate all existing rules of warfare. Military strategists from different countries understood that a future conflict would not be like previous wars. Weapons capable of changing the situation over a huge territory in a matter of seconds came to the fore. It was this new danger that forced Soviet designers to look at the tank in a completely different way. They were tasked with creating a machine that could operate where most existing models of equipment would be useless. This required rethinking almost everything, from the internal layout of the machine to the principles of crew protection. Thus began the story of a tank that would later become one of the most mass-produced, recognizable, and discussed combat vehicles in the world. But to understand why foreigners are still surprised by some features of the T-55, it is necessary to return to the late 50s and look at the conditions in which this legendary machine was born. By the time the T-55 appeared, the Soviet Union already had vast experience in creating armored vehicles. Victory in the Great Patriotic War showed the whole world the effectiveness of the Soviet school of tank building. Machines such as the T-34 and IS-2 became true symbols of their era. However, the military clearly understood that past achievements did not guarantee success in the future. After the war, the situation began to change rapidly. A new arms race unfolded in the world, in which tanks and artillery no longer played the main role, but completely different means of destruction. The advent of nuclear weapons forced military experts to revise almost all existing doctrines. What was considered reliable just yesterday could turn out to be useless tomorrow. This question was especially acute for armored vehicle designers. If previously the main threat to a tank was anti-tank guns, aviation, or enemy vehicles, now the situation looked much more complicated. Nuclear tests showed a disturbing picture. Even equipment located at a considerable distance from the epicenter of the explosion could receive serious damage. Even more questions were raised by the safety of crews. During this period, Soviet engineers carefully studied the results of numerous tests and tried to understand what the tank of the future should be.
The T-54 already existed, a very successful machine that had gradually gotten rid of most of its early shortcomings. Designers had brought its design to a high level of reliability, refined the shape of the turret, improved armament, and established mass production. But no one was going to stop there. One of the key figures in this story was the famous designer Alexander Morozov. Together with his colleagues, he continued to look for ways to further develop Soviet armored vehicles. Leonid Kartsev, under whose leadership new solutions for modernizing existing machines were created, also actively joined the work. The engineers faced an extremely difficult task. It was necessary to create a tank capable of operating in conditions that had not been considered in military affairs before. It was not just about increasing engine power or reinforcing armor. It was required to ensure the operability of the machine after exposure to factors that no one had encountered before.
Soviet specialists understood that in the event of a major future conflict, the crew would have to perform combat missions in conditions of radioactive contamination of the area, powerful shock waves, and a huge amount of dust raised by explosions. Ordinary sealing did not completely solve the problem. New approaches were required. Work on the promising machine proceeded in several directions at once. Some specialists dealt with issues of crew protection. Others improved the engine and chassis. Still others looked for ways to increase the survivability of the machine without a serious increase in its mass. As a result, a concept of a tank gradually formed, which had to combine time-tested solutions and completely new technologies. The well-proven T-54 was taken as a basis, but the future machine had to be much more adapted to the realities of the new era. By the end of the 50s, the work had reached a decisive stage. Engineers already understood that they were creating not just another upgrade of an existing tank, A machine with a completely different philosophy was taking shape before them. It had to not only fight, but also maintain combat effectiveness where most other models of equipment risked becoming useless. In 1958, the new tank officially went into mass production under the designation T-55. Outwardly, it might seem like just a development of its predecessor, but behind the familiar outlines lay a whole complex of solutions that would subsequently surprise not only the allies of the Soviet Union, but also its potential adversaries. It was then that the history of one of the most unusual features of the T-55 began. It was not connected with armor or even with armament. The main secret lay in how Soviet designers managed to combine power, reliability, and survivability in one machine, creating a tank that turned out to be ready for the most difficult trials.
When it comes to Soviet tanks, many recall their powerful armament or thick armor. However, the creators of the T-55 understood one simple thing. Even the strongest tank is useless if it is not able to reach the battlefield in time, overcome a difficult section of terrain, or continue moving after long loads. That is why special attention was paid not only to protection and firepower, but also to the overall reliability of the machine. This approach did not appear out of nowhere. Even during the Great Patriotic War, Soviet engineers bet on engines capable of operating where the equipment of other countries often faced serious problems. The legendary T-34 largely earned its reputation thanks to the V2 power plant. This engine turned out to be so successful that its further development was used for many years after the war. When creating the T-55, designers remained faithful to this philosophy. The new machine received a powerful diesel engine with a liquid cooling system.
Such a solution allowed the tank to work confidently both in hot climates and in low-temperature conditions. For an army that had to take into account the vast territory of the Soviet Union, this was of fundamental importance. The method of starting the engine is of particular interest. Unlike many foreign analogues, a compressed air starting system was used here. At first glance, this might seem like an insignificant detail. However, it was precisely such solutions that seriously increased the reliability of the equipment. The load on the batteries decreased, and the probability of a successful engine start in difficult conditions increased noticeably. As a result, the T-55 received not only decent mobility, but also an impressive range. The machine could cover long distances without refueling, maintaining high speed both on roads and on rough terrain. For the military, this meant greater freedom of action and the ability to quickly change the direction of an attack. No less attention was paid to the running gear. Engineers strengthened the most stressed elements of the structure and increased their service life. Outwardly, such changes were almost invisible, but it was they that determined the tank's ability to work for long hours without serious malfunctions. The result was impressive. The T-55 confidently overcame sections of terrain that could become a serious obstacle for other equipment. The machine passed through trenches up to several meters deep, climbed obstacles, and maintained stability even on difficult ground. At the same time, the relatively low pressure on the surface allowed the tank to feel confident where heavy machines risked getting stuck. But one of the most unusual features of the design was the fuel tanks. Soviet engineers found a solution that at first surprised many foreign specialists. Special rack tanks were placed in the bow of the hull, combining several functions at once. They not only increased the fuel reserve, but also became an additional barrier on the path of some striking elements. Such a solution allowed for more efficient use of the internal space of the machine, and at the same time increased its practical value in combat conditions. It is precisely such engineering compromises that would later be called one of the strengths of the Soviet school of tank building. However, if the engine and chassis provided mobility, the main argument of any tank remained its armament. And here too, the T-55 had something to surprise. The machine received the well-proven 100mm D10 T2S gun. At the time of its appearance, it was an extremely serious weapon. Its capabilities were sufficient to fight most existing targets, and the presence of a stabilizer allowed for firing significantly more effectively than on many machines of the previous generation. For the crew, this meant the ability to react faster to threats and deliver accurate strikes in a wide variety of conditions. The ammunition load was also revised. The designers sought to provide the tank with a sufficient amount of modern ammunition capable of hitting well-protected targets. But the most unusual feature of the T-55 did not lie in the engine or the gun at all. While Western specialists primarily thought about increasing firepower and armor thickness, Soviet engineers were solving a completely different task. They were trying to figure out how to preserve the crew and the combat capability of the machine in conditions that previously seemed almost impossible. That is why, inside the T-55, solutions appeared that were years ahead of their time and made this tank truly unique. In the late 50s, many countries continued to improve their tanks according to the standard scheme. Designers reinforced armor, increased engine power, developed new guns, and sought to increase the effectiveness of equipment in normal combat. However, Soviet engineers looked much further ahead. They clearly understood that a future war could turn out to be completely different. After numerous tests of nuclear weapons, it became obvious. Even if the tank withstood a shockwave, the crew would face new threats that did not exist before. Radioactive dust, polluted air, and dangerous radiation could turn even a functional combat vehicle into a trap for the people inside. That is why one of the main tasks when creating the T-55 was to protect the crew from factors that just a few years ago seemed like something out of science fiction. To begin with, the designers solved the problem of contaminated air entering the machine. It would seem like a simple task, but in practice, it required huge work. Even a small crack could nullify all the efforts of the engineers.
Therefore, specialists literally revised the entire sealing system of the hull and turret. Every hatch, every joint, and every technological opening underwent thorough refinement. As a result, it was possible to achieve almost complete tightness of the internal space. This was an extremely important achievement for its time. However, sealing alone was not enough. The crew could not stay inside a completely closed tank without a constant supply of fresh air. A logical question arose: how to provide breathing for people while simultaneously preventing dangerous particles from entering the machine? The answer was a special air filtration system. Before reaching the combat compartment, the airflow passed through multi-stage cleaning. Filters trapped contaminants, after which the purified air was fed inside under increased pressure. This solution proved to be quite effective.
The increased pressure inside the machine created an additional barrier for the penetration of contaminants through possible microscopic gaps. Even if a small leak appeared somewhere, the air tended to go out, not get in, along with dangerous dust. But the work did not end there either. Tests showed that there was another serious problem. Even if the crew was completely isolated from the external environment, there remained the impact of radiation. To combat this threat, Soviet specialists introduced a solution that subsequently became one of the most unusual features of the T-55. It was about the so-called liner, podboy. It was a special protective material placed on the internal surfaces of the tank. At first glance, it looked quite inconspicuous, but it performed several important functions at once. First of all, the liner reduced the impact of penetrating radiation on the crew.
For its time, it was an extremely progressive solution, since such tasks had practically not been set before designers of armored vehicles. But it soon became clear that such a material had another important advantage. During projectile hits, even the strongest armor could create dangerous secondary fragments. Tiny particles of metal tearing off from the inner surface of the hull posed a serious threat to the crew. The liner helped to reduce this risk by holding a significant part of such fragments. In fact, one engineering solution solved several problems at once. It was precisely such approaches that distinguished the Soviet school of designing military equipment from many foreign analogues. Later, the idea was further developed. In certain parts of the structure, additional protective elements began to be used, which increased the overall safety of the machine and increased its resistance to various impacts. For foreign specialists, many of these solutions looked unusual.
They expected to see another reinforcement of armor or a new gun, but instead, they discovered a huge amount of work aimed at preserving the combat capability of the crew in the most difficult conditions. It is here that one of the main reasons for the phenomenal popularity of the T-55 begins to be revealed. This tank was created not only as a means of waging war, it was designed as a machine capable of continuing to perform its task when the surrounding environment became extremely unfavorable. Over time, it was this approach that made the T-55 the basis for a huge number of various combat vehicles. Its design turned out to be so successful and versatile that a whole family of equipment began to form around it, the scale of which few could have predicted at the moment of the tank's appearance. By the early 60s, it became finally clear that the T-55 had turned out much more successful than many expected. Initially, it was created as another step in the development of Soviet medium tanks, but it very quickly turned out that the potential of this machine significantly exceeded initial calculations. The military especially appreciated one important quality. The T-55 did not require any complex operating conditions and could effectively perform tasks in a wide variety of climatic zones. The machine felt equally confident in hot deserts, on dusty steppe roads, in high humidity, and on rough terrain. It was this quality that subsequently played a huge role in its global career. Gradually, interest in the Soviet tank began to show far beyond the borders of the USSR. Many states carefully studied the capabilities of the new machine and came to the same conclusion. Before them was a tank that combined good firepower, reliability, ease of maintenance, and relatively low operating costs. For the military, this was an extremely important advantage. After all, equipment must not only perform well at a testing ground, but also maintain functionality in real conditions, where there is far from always a developed repair base or the ability to quickly receive the necessary spare parts. The T-55 possessed exactly that set of qualities that allowed it to work effectively even in such circumstances. Its technical characteristics were also highly appreciated. For its time, the machine demonstrated quite decent speed, good mobility, and balanced dimensions. It did not look overly bulky, but at the same time, it retained impressive combat power. It is not surprising that the T-55 soon began to spread rapidly around the world. It was purchased by allies of the Soviet Union, produced under license, and actively used in various regions of the planet. Over time, this machine became one of the most recognizable tanks of the second half of the 20th century. However, the true value of the design was revealed a little later.
Engineers quickly realized that the chassis and general layout of the T-55 had a huge reserve of opportunities for further development. Instead of creating completely new platforms for each task, it was possible to use an already proven foundation. Thus began the history of a whole family of machines that appeared based on the T-55. On its platform, flamethrower tanks, engineering vehicles, repair and recovery equipment, bridge layers, and many other specialized models were created. Some were intended to support the offensive, others ensured the overcoming of difficult sections of terrain, and still others were engaged in the evacuation of damaged equipment directly from the combat zone. Such versatility was not always met. Many tanks coped perfectly with their main task, but turned out to be unsuitable for creating a large number of specialized modifications. In the case of the T-55, the situation turned out completely differently. In fact, around one tank, an entire ecosystem of military equipment gradually formed, capable of performing the most diverse tasks. This additionally increased the interest in the machine on the part of foreign states and further strengthened its reputation. But even then, the story of the amazing features of the T-55 does not end. Over the years of service, the tank repeatedly became a participant in various tests and experiments. Some of them were quite expected. The reliability of the components, the service life of the engine, the cross-country ability, and the resistance to various loads were checked. However, one experiment turned out to be so unusual that it was later talked about even outside the Soviet Union. The military and engineers wanted to get an answer to a very strange question. What will happen if, instead of ordinary diesel fuel, the tank is refueled with the most common raw material from which this fuel is subsequently produced?
At first glance, the idea looked almost incredible. But it was she who led to one of the most unusual tests in the entire history of the T-55. And the results of this experiment surprised even those specialists who were initially confident in the capabilities of the Soviet machine. By the mid-80s, the T-55 had long been considered one of the most famous combat vehicles in the world. Behind it were decades of service, numerous upgrades, and vast experience in operating in the most varied conditions. It would seem that engineers had managed to study this tank inside and out. However, it was then that an experiment appeared that was supposed to test the capabilities of the machine from a completely unexpected side. The occasion for the test was a question that at first glance looked quite strange. Can a tank engine work not on diesel fuel, but on ordinary crude oil? For most specialists, the answer seemed obvious.
Oil differs significantly from ready-made diesel fuel in its characteristics. It contains many impurities, has a different viscosity, and behaves completely differently in the fuel system. Therefore, many expected that the experiment would end almost immediately after the first attempt to start the engine. But Soviet engineers decided to test this in practice. For the purity of the tests, the design of the machine was not subjected to serious changes. The engine remained standard. The fuel equipment was also not modified. Researchers wanted to see the real reaction of the machine to such unusual fuel without any additional improvements. The tests were conducted in the summer, when the air temperature exceeded 20 degrees. The conditions were most favorable for starting the engine. On ordinary diesel fuel, the T-55 in such a situation started almost instantly. The crankshaft required a minimum rotation, after which the power plant confidently entered the operating mode. When oil was poured into the tanks, the situation changed immediately. The first start showed that it had become significantly more difficult for the motor to reach operating speeds. Instead of the usual quick start, the engine tried for a long time to reach the necessary operating mode. The crankshaft made several rotations in a row before the power plant finally came to life. To rule out chance, specialists repeated the experiment many times. One start was replaced by another. The results were recorded, compared, and analyzed. Gradually, it became clear that the engine was still capable of working on such unusual fuel, although the starting process was noticeably complicated. If on diesel fuel, the start took seconds, then on oil, it took significantly more time. For a combat situation, such a delay was extremely undesirable, but the very fact of a successful start already looked very impressive. But the most interesting events began after the engine warmed up. Thick, dark smoke poured from the exhaust system. Along with it, tongues of flame periodically appeared. The spectacle looked so unusual that many participants in the tests later remembered it as one of the most vivid moments of the experiment. When the tank began to move, the effect became even more noticeable. The exhaust was accompanied by flashes of flame that at times burst out to a significant distance behind the machine. From the side, it looked as if not an ordinary tank was moving across the testing ground, but some experimental equipment from a science fiction film. However, external effects interested the engineers least of all. The main task was to understand whether the T-55 could perform real tasks when using such fuel. Therefore, the tests continued. The machine was sent on a route including various sections of terrain. The ability of the engine to maintain power under load, the stability of the power supply system, and the overall reliability of the equipment were checked. Each new stage was supposed to show exactly where the limits of the tank's capabilities were. It was then that the first serious drawbacks of such a solution began to appear. But despite all the problems that arose, the T-55 continued to move forward, again demonstrating the quality thanks to which it received worldwide fame. The reliability that was laid into this machine, even at the design stage, allowed it to work even in conditions that many specialists considered almost impossible. But the most interesting part was yet to come. The next tests were to show how much the use of crude oil affects speed, cross-country ability, and fuel consumption. It was these results that subsequently aroused special interest not only in the Soviet Union, but also far beyond its borders.
After the successful start of the engine and the first kilometers of movement, the tests moved into the most important phase. Now, engineers were interested not in the fact that the tank worked on crude oil, but in its real capabilities in such conditions. It is one thing to make the machine move, and quite another to check how effectively it can perform familiar combat missions. For this, the T-55 was sent to a special track with various obstacles and sections simulating difficult terrain. The machine had to overcome climbs, gain speed, and work under load just as it would in real operating conditions. The first results were expected, but still impressive. When driving uphill, the tank retained the ability to confidently overcome obstacles, but the engine worked noticeably harder than on standard fuel. Each acceleration required more time, and the machine's reaction to the driver's actions became less energetic. This was especially evident during the acceleration dynamics check.
On ordinary diesel fuel, the T-55 demonstrated quite decent indicators for its mass and class. However, after switching to oil, the situation changed. To reach a speed of 30 kilometers per hour, the machine required significantly more time. The difference was so noticeable that it could not help but be recorded in the final reports. Nevertheless, the most amazing thing lay in something else. Despite the degradation of characteristics, the tank continued to perform assigned tasks. It did not stop after the first kilometers of the journey, did not lose the ability to move, and did not turn into a stationary target. For many specialists, this was enough to call the experiment a success. However, another problem soon emerged. Fuel consumption began to increase rapidly. If on diesel, the machine showed quite familiar results, then when using oil, the engine's appetite grew noticeably.
For military equipment, this was of great importance, as range was always considered one of the key parameters. But even increased consumption was not the main drawback. Engineers were much more worried about the state of the fuel system. The oil contained a large number of components that standard filters encountered extremely rarely. As a result, cleaning elements began to clog much faster than the calculated values. After a relatively short time of operation, the filters gradually lost efficiency, and the engine began to experience a lack of fuel. Interruptions in work appeared, power decreased, and sometimes the power plant stopped working altogether until maintenance was carried out. And yet, despite all the difficulties, the experiment achieved its main goal. Soviet specialists received proof that the design of the T-55 possessed a huge reserve of reliability. The machine was able to work on fuel for which it was not originally created at all. Moreover, it continued to move, overcome obstacles, and follow the crew's commands. Such results aroused great interest among military analysts. Specialists outside the Soviet Union followed such experiments very carefully. The possibility of using such unusual types of fuel was seen as additional confirmation of the exceptional survivability and unpretentiousness of the Soviet machine. But the real reason for the global popularity of the T-55 lay not in experiments with oil at all. Over decades of service, this tank has proven much more. It has survived many generations of armored vehicles, has become a participant in a huge number of armed conflicts, and has managed to remain in demand when many of its contemporaries have long turned into museum exhibits.